Hey guys, just redoing a lesson video because unfortunately I said $7.50 was a unit of measure for distance, so I made a mistake there. Just redoing it for you to be correct. So in maths and science, we're often concerned with the relationships between variables. At this level, we only look at two variables at a time. When we look at two variables, one of them is considered the independent variable, the other is the dependent variable. It's important to define both of these as definitions apply within both maths and science subjects from now on. So the first notes that you should be getting is, in any relationship between two variables, the independent variable is the one that causes the other variable to change. The dependent variable is the one that changes because of changes in the independent variable. And lastly, you need to identify these because when you graph them, the independent variable always goes on the x-axis and the dependent variable always goes on the y-axis. So if you're taking notes, you would pause here so you can get that stuff in blue, but I'll move on for this video. So the most basic way of displaying linear relationships between two variables is with a table of values like this. You'd want to put the independent variable in the top row and you'd put the dependent variable in the bottom row. Why is that useful? Well, a table like this makes it clear when you have a linear relationship between the variables because you'll see the independent variable changes up or down a constant amount and the dependent variable changes up or down also a constant amount. So let's examine here. 5, 4, 3, 2, 1 is reducing by 1 each time. 2, 5, 8, 11, it's increasing by 3 each time. Therefore, we could say that this is a linear relationship in that table versus this table here. Yep, that went up by 1, but now it went up by 2 and then it went up by 1 again versus plus 2, plus 2, plus 2. Even though the y variables looks like they're going up linearly, both x and y have to go up by the same amount each time, and this didn't go up by the same amount each time, so this would be non-linear. So again, another opportunity to pause and get that set of notes down and the two tables. But for this video, I'll move on to the example. Consider the relationship between the cost and the distance of a taxi ride shown in the table below. So the distances traveled is no distance, 1k, 2k, 3k, 4k. And the cost, travel no distance, you get in the taxi, it's going to cost $5. Travel 1k, $7, $9, $11, $13, which is the independent variable. The independent variable is going to be the distance because the distance traveled determines the cost. Which is the dependent variable, the cost, because it changes depending on distance traveled. C is the relationship shown linear. Well, plus 1, plus 1, plus 1, plus 1, plus 2, plus 2, plus 2, plus 2. So it is linear because x increases by 1 always and y increases by 2 always. How much would a 7k journey cost? We don't currently have that information in the table, but because it's linear, we can add it. 3, 4, 5, 6, 7. This is going up by 2, so 15, 17, 19. So how much would a 7-kilometer journey cost? $19, according to the table. How far could you go with $20? I don't have 20 in there, so let's extend it. 8 is going to be 21. So unfortunately still, I don't have 20, but I can use logic and reason to work that out because halfway between 19 and 21 is going to be 20. Therefore, halfway between 7 and 8 is going to be 7.5. How far could you go with $20? Oh, I stuffed it up again for this video. 7.5 kilometers. All right, so your homework, and now can you do exercise 12A, linear relationships, question 1, 2AC, 3, 5, and 7. Hopefully that helps you out, and see you in the next video.